Hi everyone, welcome to Snug Chocolate, a show about ZK products where we break them down with rich flavors and sweet insights. I'm Omer, and today I'll be co-hosting with Queenie. We're super excited to have Teemu Päivinen, CEO and co-founder of Gevulot. So hi Teemu, it's a pleasure to have you here with us on this podcast. I guess that maybe you can start by introduce yourself and Gevulot.
Well, hello everyone. My name's Teemu. I'm the founder and CEO of Gevulot. And Gevulot is building what we call ZK Cloud, which is a universal proving layer or prover network. The vision is basically to build a decentralized platform to do all of the ZK compute from across the industry.
Very nice, very ambitious. Let's start with the basics. So, can you share more about the design of the network? Also, what makes it so well positioned for ZK proving?
Yeah. Well, the design, we can probably dig into very different areas depending on what you guys are interested in. But basically, the way it works is there's a blockchain. The blockchain doesn't do very much. It kind of handles orchestration, scheduling, and the economics. And then there's a whole bunch of, so there's like the blockchain is run by a set of validators, and then there's a whole bunch of prover nodes which provide the actual compute for doing the ZK proving. And so in a way of conceptualizing it is that the validators kind of oversee a large number of prover nodes that do the actual compute. So you have, let's say you're a project that's running a risk zero ZKVM, you're like a roll up like Tycho or something. You can deploy a custom version of the risk zero prover, or you can use like a standard one that we've pre-deployed. And when you deploy, you just create a transaction where you basically give a URL to the prover where it can be downloaded. That gets distributed to the prover nodes that can facilitate proving for that. So like if you need GPU proving, that gets distributed to GPU nodes, and if you don't, then it goes to CPU nodes. So they all, basically every prover node that can provide the compute you need will have the prover and is able to generate a proof at any time for you. And then you create transactions, pass inputs into those provers. Those get allocated randomly to provers that have capacity and have the hardware needed to compute the proof for you. This is the sort of the simple version. So you get random allocation, a prover computes the proof, you get it back, everyone's happy. The network then verifies the proof and distributes rewards. In practice, there's a little bit more complexity. We build fallbacks and kind of not security, but execution guarantees, I guess, via the economics into that flow. But that's the high level.
Very nice. Right. So maybe you can share a little bit more on where you are on your journey. What are the next milestones? What have you built already?
Yes. Well, maybe a brief history. So Gevulot announced its sort of, I guess, our intentions back in, I think it was November of last year. After that, we launched what we call a DevNet. Maybe it wasn't a great name because it is an actual functional network. It's just relatively naive. It doesn't do sort of allocation, doesn't have any sense of capacity, etc. So it doesn't scale. But it sort of performs the basic functions, and people could start trying out deploying provers, running workloads and things. There's over 400 provers that have been deployed on the DevNet. Something like 2.5 million proofs have been generated. So that was launched in March of this year. And since then, we've basically been focused on launching a production version of the network. Which is now hopefully, fingers crossed, nothing goes horribly wrong, but is hopefully going to launch in the next couple of weeks. And what that is it's basically our mainnet implementation. So it has a chain, it has it sort of all the structures in place that will exist in mainnet, but we're going to run it in a permissioned way. So basically, we will run all the validators, but there's external hardware providing the compute. And the reason we're doing that is because basically there's a lot of proving demand that's coming online right now. Every sort of production use case requires quite a lot of compute, and so you need something scalable, and you also need something very reliable to like start actually onboarding that demand. And so the thinking here is to provide kind of a stable foundation that is very similar to what mainnet will be, to let people start using it in practice. One big sort of benefit why people are quite excited about it is that it is very, very cheap. And so the economics as well are reflected, are basically the same as they'll be on mainnet. So it's about 95% cheaper than AWS on both CPU and GPU workloads. And once we have that, then we're going to sort of move forward onto testnet. Basically, that means just letting other people run validators, testing out, having sort of external parties involved in consensus. And then after that, mainnet. And so this next launch is Firestarter, then we have testnet, and then mainnet. Firestarter will basically continue to run until mainnet is stable and sort of reliable enough where we feel comfortable moving the projects over to that. So that's kind of the overall thing. We're targeting right now Q1 for mainnet, and as said, Firestarter hopefully here in like 2 weeks.
Fantastic. So after Firestarter, Deluge will be the next one, right? And the biggest goal for Deluge is transit from a permission network to a decentralized network.
Yeah. So Deluge is what we're calling the testnet, and that will be having other. So right now it's permissioned in the sense that we are running all the validators, but the actual consensus of the chain works in a permissionless way. We're just not letting people participate.
I see.
And so testnet will be having external people participating. But all of those, like all the economics of staking, et cetera, have already been implemented in Firestarter. But we haven't done like an actual test, and given that we're targeting sub-second block times, we do need to test out sort of how everything runs. Where the chain is built on Cosmos SDK, and there's a fair amount of messaging overhead. So we need to kind of see what that all looks like when we have, international, like geographically distributed validators, and there's all kinds of quirks, like depending a little bit on what kind of distributed signing systems people use, they can create overhead and could create problems with people being able to actually do messaging on time and so on. So we need to test all that in testnet, but yes, the testnet will be permissionless, and probably like incentivized, and then next step is just mainnet launch.
Awesome. Curious, what are the key challenges in designing a decentralized, permissionless prover network?
There are many. I think, well, there's kind of challenges on many fronts. So like on a design level, there's like a lot of paths that people are exploring or have explored, and like just to illustrate kind of different options, if you wanted to do some kind of like proving network type thing, it's not necessarily the best name, but there's like a couple of ways people are approaching it. One, you could have some kind of smart contract based system that, for example, runs an auction or has some other mechanism for deciding who is in charge of generating a proof. You have these sort of marketplace type things like Nils Proof Market, Minas Marketplace, and then there's the approach we've taken, and a lot of it has to do with our general belief that it's actually important to try to distribute the compute. There's sort of an ideological reason behind it, which is that if you have like a purely monetary or performance-based workload allocation mechanism, then you very easily end up with like one party that does kind of everything. So let's say you have an auction. A lot of these workloads are quite big, is maybe one way of thinking. Like you might need 100 servers to be able to participate in a lot of proving for different rollups. And so if you think about it, like if you don't win the auction, like, I don't know, 50 times in a row, are you going to have 100 servers just sitting around waiting for if you win the next one? Probably not. And so you have these kind of centralizing forces. And the other reason is simply that because the amount of compute needed for a lot of these is so large, it's actually kind of problematic for any single company to like produce that amount of hardware and commit that amount of resources. But if you kind of crowdsource it from a larger pool of participants, it becomes a little bit easier. So everyone's sort of financial investment and financial risk is much more contained and localized than if you had a single company try to do the whole thing. So that's one area of challenging or of that has been challenging. The economic or the sort of execution guarantee side of things is also quite tricky. There's this kind of conflict between people wanting the proving to be cheap, but then also wanting it to be very like having a strong guarantee that the proof will get done. And these things are in tension because like actually nobody wants to pay for redundancy, but the way to ensure that something happens is redundancy. And so you need to kind of balance these out. And the way we are approaching that after talking with a lot of projects over the past year or so is basically that instead of redundancy, you want elegant fallbacks. So the cost is kind of the primary consideration, but then you need to be able to kind of recover very quickly if something goes wrong. But there's definitely all kinds of trickiness there. And there's all manner of other areas, like if you have a very large parallelized workload, like there aren't really any right now, but like let's say that you want to prove Ethereum mainnet blocks using RISC-0, you probably want to split the block up into, you know, something between 5 and 12,000 segments. Segments are like, they're like little pieces of the execution trace that you can prove in parallel. And you may have, like said, like 12,000 of these, and then you distribute those to a large amount of GPUs so you can do very quickly things in parallel. And the tricky thing with a decentralized network is that you kind of inherently incur some communication overhead if you do this very naively. And so then you need to design ways in which people can optimize this, which basically comes down to like you need to give people the ability to very sort of granularly define how to maximize the utilization of a single server so that you don't do any unnecessary kind of communication over the network. But yeah, there's all manner of technical challenges.
Sounds like a very complex, multi-dimensional competition design. But I guess
Yeah.
you figure out the right direction to go.
Yeah, I mean, we certainly hope so. I mean, we're quite confident that it is the right direction. And a big part of that confidence is just so the pricing structure for this is going to be like ludicrously cheap. So on the GPU side, like if you fully utilize a node, which is a dual 4090 64 core 386 or whatever it is gigabytes RAM machine, you pay what I think is 0.8 dollars, so like basically like 80 cents an hour. In practice, what you pay is for the resources used. So like if you only use one GPU, you only pay for half a node, and then your compute time. And so the costs end up being dramatically lower than anything that's on the market today. And I think that unlocks a lot of things. Like the most immediate thing is for the long tail of people deploying rollups on the different stacks, like, you know, Polygon CDK, ZK Stack, Scroll SDK, etc. For them, proving costs are very material because they don't necessarily have hundreds of millions in funding. And they're like, so you can think of it like there's some amount of projects that are viable now with like the cost structures that exist currently. And then there's like a whole nother spectrum of projects that become viable if the cost structure is different. So yeah, we've been quite excited, and we've had a lot of very good feedback that it probably is the right way to go.
I want to unpack what you just said a bit, actually taking it in two directions that I'm curious about. One is what's going to be the end game, or how the end game is going to look like. I mean, happy flow, right? Like, let's say we reach adoption and everybody is happy. So how, maybe you can sketch how this is going to look like. The other thing I wanted to ask is about, so I've seen that Gevulot is being positioned as a ZK cloud, right? And you also mentioned the cost reduction, and you compare it to AWS already. So I was wondering if you can elaborate more on this type of positioning, like what like differentiates you, and how do you plan to maintain this like differentiators compared to public cloud? How do you maintain this like low cost over time?
So on the ZK cloud bit, like I think the very long term vision really is more around like computing in general and less around like roll-ups or blockchains. So the way, like, I mean, this is all fairly obvious for anyone who is familiar with ZK, but really what ZK allows us to do is stop re-executing, which if we get performant and cost-efficient enough algorithms, means we can start doing computing in a very similar way to how the clouds do it now, except you get it from a decentralized context. And so I think that's the really exciting piece. So I don't know exactly what it's going to look like in the end, but you can imagine kind of the risk zeros and SP1s and the Nexuses and Jolts and whatnot, ZKVMs of the world, as they get more and more performant. At some point, the difference between just running something natively and running it in one of these is going to be small enough to justify people doing that for a large variety of use cases. And I think that extends beyond just blockchains. In the more kind of immediate term, the use case that's most clear is obviously in the blockchain landscape, because we're like ZK is kind of competing with re-execution, and re-execution is so inefficient. So it justifies using that. Or ZK is, even with higher overhead, is justified to be used in many situations. So that's kind of the direction that we want to go in the long term. I'm still a believer in kind of this idea of the world computer or something like that. I feel like, you know, Filecoin and Arweave and a lot of projects, I mean, Ethereum back in the day, ICP, like we kind of took things in that direction. We didn't quite figure it out. And I think a big part of why we didn't figure it out because we didn't have anything like ZK. And so we were forced to kind of compromise security in order to get the type of user experience and performance that people want. And to be fair, ZK isn't there yet either, right? Like ZK overhead, I mean, you would probably know better than me, but it's probably like 10,000x native computation, something like that. But I think that's going to drop quite dramatically. Like we have like hardware stuff that's probably going to do maybe 100x. I think just based on like algorithm and implementation maturity things, we probably get 10x. We haven't even really like moved everything over to GPU yet. So I'm optimistic about that. It will take a little while to really get there, but in the meantime, the blockchain space, I think, will benefit greatly from this. Like the same sort of applies. Like any cost reduction and improving sort of directly translates into more competitive rollups, more competitive coprocessors, et cetera, et cetera. And so that's kind of what we aim to do in the near term. You kind of asked something else, but I forgot what it was.
I think pretty much covered my question. I mean, I was interested also in like direct comparison with AWS. Like, how do you compare? How do you measure? And what makes Gevulot different?
Right. Yeah. So it's a good thing. So on AWS, we're basically just benchmarking like against on-demand pricing. So everything in Gevulot is on demand. We don't have like a concept of commit for 3 years or whatever. We are cheaper than AWS, even if you do commit for that extent of time, but the fair comparison is still with on-demand pricing. CPU is pretty straightforward. We just like find basically the like cheapest configuration that sort of resembles our CPU nodes. Our CPU nodes have much more modern hardware. Like if you get a cheap box from AWS, like you're probably on 3 generations old hardware, but it's, that's at least theoretically like the same thing. GPU is a little bit harder because you can't actually get the GPUs we have. So we have 4090s on our GPU nodes. So I think the closest comparison from AWS was L40S, which is quite a bit slower than a 4090. But the cost comparison is sort of relevant. So like 95% cheaper than an L40S, but you get a 4090, so it's faster. Is kind of the way we've been benchmarking it. I don't remember the exact instance name of that, but there's kind of like.
But the point is that you are basically differentiating on like the hardware, of course, the cost of the hardware, but also the algorithms to run on the hardware. Like you also optimize the way that you utilize the hardware, and it means that Gevulot would basically have this optimal set of hardware, as you mentioned before, for the supply side of things, right?
Yes. Yeah,
Okay.
that's broadly speaking. I think that the way you get cheaper is like a combination of hardware choices and incentives. So the economics matters quite a lot. I think blockchains are kind of like optimal search algorithms for the cheapest compute and bandwidth and electricity, etc. And there's just like being able to kind of incentivize many very localized pockets to figure out optimal solutions to deliver compute to you is, I think, much more powerful than any single company trying to do it. You give up something in the process because you do get some overhead and things like that. But that's, I think, the long-term reason. So you kind of you want to incentivize the right kind of hardware to join the network, and you want to have a lot of people all over the world thinking about how to achieve that. And then you need to sort of efficiently utilize that hardware. So we spend a lot of time thinking about how the orchestration works on a node, because that matters quite a lot. So our nodes are like bigger than most actual workloads. And so you want to be able to run, 2, 3, 4, 5 workloads at the same time, and you need to make sure that they all complete on time. And how do you like manage the resources there? But yeah.
Do we want to get into the mechanism design? I feel like it's like a rabbit hole that might
It's a
deserve like,
long
yeah.
it's a long rabbit hole. But I think I think like the economic side is kind of probably more important in the end. Like you just have demonstrations. Like if you look at Bitcoin mining, like I don't think there's any way to centrally replicate what has happened in the Bitcoin mining industry over the past 10 years. You could look at the Alio mainnet beta, as they're calling it. There were like 200,000 4090s that joined the network or were mining the network. And this is like went from 0 to 200,000 in like a couple days. And so that type of like, and by the way, the cost structure was like ridiculous. So on the Alio mainnet beta, I think per year, you wouldn't make well, this depends a little bit on the amount, but basically you wouldn't make money. Yet there were that many 4090s. So there's also this like latent compute. Like there's people sitting on GPU farms that are sitting idle. And like if you're able to utilize them, like those people have a cost structure that like is very different to if I go and buy a machine and do something, right? Like their cost structure is electricity and bandwidth, and that's it. Maybe some like man hours for setting up some new thing, but they're not like trying to pay off the hardware anymore or anything like that. They're trying to utilize hardware that they already have. And I think if you look at this globally, like that's a very powerful thing. It's sort of going back to what, Filecoin was pitching. It's like, oh, there's all these, everyone can attach their hard drive. I'm not a big believer in like every retail person, like, connecting their laptop to anything. But I do think this latent compute exists even on an institutional level. So that's really, I think, what we want to tap into, and it's quite difficult for any centralized provider to replicate that.
Very interesting. Probably, yeah, deserve a separate discussion. I want to go back to talk about more of like product and roadmap, and try to kind of like place two things we've seen being put in motion by you guys. So one thing is this insane amount of partnerships. Wonder if you can elaborate on on the strategy and what are the plans in how to work with like all of these like partners. And the other thing is that your name comes up also in relation to different proof of marketplaces, experimental. So to name a few, I know that you recently had a great success with Aztec. ZK Sync is another one. So again, what's the play? I mean, how does it fit into the product strategy?
Yeah, so I mean, I wouldn't describe Aztec and ZK Sync as like proof of marketplaces. They have proving needs. They have some mechanism for deciding who is going to generate the proofs. We want to participate in those. But I think the simple answer to kind of like the product strategy is that we're aiming to be maximally horizontal. And the way to do that is to compete on cost. We don't actually care where the demand kind of comes from. So we're happy to participate in other prover marketplaces if they have demand. I don't care. Like if we can like offer rates that are cheap enough to sort of participate there, and they can still take a cut, that's perfectly okay for me. We're not trying to capture. So there's like an inherent kind of arbitrage between the actual source of demand and kind of the compute provider, right? And we're not trying to capture that arbitrage. We're trying to capture the cost of compute plus a margin. So really very much like an Amazon, as large volume as possible type game that we're playing. And so we don't really have an issue working with other folks. And with the rollups, like they will have some mechanism by which they decide who generates a proof. We have built basically integrations into all those mechanisms, and so people will just be able to run this kind of like proxy client that participates in the Aztec bidding. I'm not going to go into how the mechanism exactly works now because it's a long story, but and then it offloads stuff to Gevulot. So like you can just run that and you can capture that arbitrage. And the same kind of exists everywhere. So we're doing proving for Nexus. We're doing proving for ZK Sync and Aztec. We're planning to do proving for basically everyone else as well. In regards to the partnerships, I think there's kind of two general angles. So like we obviously have partnerships with potential clients, people who need proving. We also have partnerships with projects that kind of our clients may want as well. So as an example, like partnered with Espresso because you might want to have, like if someone may want to package decentralized sequencing proving and DA into the same thing. And then you have like the verification projects like ZK Verify and Aligned Layer and things like that. So that's the two main area, or like we kind of have clients and then we have people elsewhere in the stack that may want to exist in the same kind of package. And then we have ZK Boost, which is kind of a slightly separate thing, but maybe worth mentioning, which is kind of like an abstraction for proving. And there we're partnered with a whole bunch of people. Is going to be a big announcement at some point here. But that it's a little bit different because really there the intention is to create a neutral entity that just like creates basically a standardized API for proving. And the reason we wanted to do that is because we sort of saw we built integrations with everything. There's a lot of maintenance there. Everyone else is going to have to build integrations with everything. And then the like roll up or whatever, like they don't have any incentive really to try to like help these proving providers maintain their integrations because they might all work a little bit differently and all this stuff. So the point really is to give them a standardized API and be like, do not break compatibility with this one API. And then you will have proving. If it breaks, then you lose all your proving. And that will hopefully simplify things kind of for the whole industry. And so we benefit because we hopefully have to do a little bit less maintenance work. And hopefully everyone else benefits for the same reason.
Interesting. I have a quick follow-up question here, and then we can come back to ZK Boost. So I'm curious, is there a possibility that the protocols you just mentioned will eventually build their own prover networks? And if so, how does Gevulot fit into or complement their initiatives?
Well, I mean, the kind of like the term prover network is a bit tricky because it's not clear what it means. So any roll-up will have some mechanism by which they decide who is responsible for proving. If you want to think of that as a prover network, then we'll all have prover networks. But if you think of prover networks as something slightly more generic, then it's not quite that. And I think from the perspective of the rollups, right, like they actually want something that's relative, that they're interested in security and like they want to make sure that things work, and I think it's generally easier for those to be quite simple. So like I don't know if this is controversial or not, but I actually think the best way to do that for a rollup is just to like offload the whole problem to the sequencer. Once you start formalizing anything, you immediately get into a much sort of stickier design space. And just offloading the whole problem to the sequencer actually works. They're already staked. They have a lot of different options for how to do proving. They could run provers themselves. They could offload to someone else. They can use Gevulot, etc. And I think in the end, most will default to that. Of course, if you have like a stack, like a ZK stack or a Polygon CDK or whatever, you might want to have some collective method for doing that. That might look more like a prover network. It's a little bit unclear. We kind of have the same approach there as well. Like we sort of don't care. Like we're just going to participate in all these things, or have people who kind of offload to Gevulot participate, and it doesn't really matter to us. And then ultimately, like in terms of a business model, let's say a prover network for ZK stack projects, like that's not going to generate enough fees to like be very material in the context of a potentially like 100 billion ecosystem in some time in the future. So I think there's this general, and there's a lot of this narrative going on. Like a lot of ZK projects are kind of going up and down the stack. Like they're building their own ZK VMs. They're becoming prover networks. Like it's, it's kind of funny, but I think generally speaking, the value, like unless you cover a huge amount of ground horizontally, it's always kind of a much better value capture mechanism to go up the stack towards basically the end user, i.e. do a roll up or have some monetization mechanism that's directly related to the success of the tokens that are deployed by the rollups or something like that. Because that's ultimately where the value gets captured. So the one example I like to use on this stuff is like, wouldn't it be like a pretty big bummer if if the biggest roll up ever is just running risk zero, and risk zero can't monetize or like can't get anything from that, which is possible because you can just use it. You don't need to give them any money. And so I think that already sort of clarifies the dynamic a little bit. Like ZK VMs probably become kind of commoditized, and it becomes more and more important to be kind of closer to the end user. Assuming the whole market is big enough, then these like horizontal layers underlying these structures can also be valuable, but only in sort of large volume.
So, as you said, Teemu, there are many narratives going on in the space.
Yeah.
So I guess that's why there's also confusion in the definitions in like prover networks, prover marketplaces, and like, all these various roles in the proof supply chain. And I guess that's because the different roles, they're actually operating so close to each other. So they kind of like are moving here and there, so which caused even more confusion. So I guess that's like one of the reasons that you introduced ZK Boost, which you actually aggregates like many things, many components together, and then move like more to the upstream.
Yeah. I mean, the very first step for ZK Boost is just to be a proving API, but it certainly can potentially become like a broader abstraction as well. I think one reason that there's so much confusion on the narratives is because like most people just don't care that much what happens kind of under the hood as long as it works. And so maybe that's kind of the way that we should be thinking about these, is how do we make it just not really visible what's happening, like just very, very easy. But I think things are moving in that direction slowly, and we'll obviously hope to contribute to that path.
So what's the call to action if I want to participate in Gevulot or ZK Boost? What should I do? Who are you targeting at the moment, and how can I interact with the network at the different stages?
Yeah, well, right now, like the immediate actionable for Firestarter is if you want to run prover nodes. We are onboarding prover nodes actively. You can just get in touch with us on Twitter or on Telegram. In a couple weeks' time, you'll be able to actually start proving on Firestarter. The way that it will work is that you purchase credits with a credit card. Like, these are tokens that you can't sell, essentially. Like, it's just the blockchain is doing the accounting of like what you've used. So similar to like Amazon credits or Google credits. We also have free tiers that you can apply for, but you need to get some credits and then you can start using it. And all this will be included, or like this will be made very clear in our documentation and on our website, which is gevulot.com. If you're not wanting to run a node and you don't want to wait a few weeks, then you can also still deploy things on the DevNet and play around with that. That's up and running and is free to use.
So I have another question, and I'm a bit afraid of the answer, so I'm going to ask it quietly. What about privacy? Have you thought about ZK for privacy?
Yeah, it depends a little bit on what you mean. Do you mean like privacy of the inputs for provers?
Yeah, of the witness, exactly. Yeah.
It's a good question. So I think there's like, let's take case Aztec, right? The sort of end user generates the first proof with a private witness, and then we can do all the aggregation proving after that. And that is kind of the designed flow anyway. You want the end user to do that because that's kind of where the privacy comes from. There are people who are working on like MPC or T based solutions for doing proving. I don't see the use case right now for that. Like in terms of like an immediate commercial use case, I'm not sure what it would be used for. Maybe Alio or Aztec users will want to offload their like local proving. But there's, I think, very big question marks around whether that actually is the case. So the easy example, so you always incur some overhead. You kind of add, regardless of how secure it is, like you do add another potential attack vector or a vector of losing your privacy if you're handing over your data to someone else. But then the question becomes like, how much better is it, and does it actually improve the user experience dramatically? So like, maybe if like it takes 3 seconds by offloading to some TE based system and otherwise it would take you an hour, like that might be justified. Are people going to pay for that? Maybe. But we currently don't really have examples of programs on these like chains that have private state, which would have those dynamics. And generally speaking, a lot of it is more like, okay, you can do something like 40% faster or something like that, 50, 60. But if it's a question of like, do I wait for 3 minutes or 10 minutes? Like, I'm not sure it actually matters so much that the end user is going to pay for it. Like if it's longer than 2 minutes or a minute and a half, I think then it kind of doesn't matter whether it's 8 or 9 or 10 or 15, like you're waiting anyway. And so the commercial value of that kind of proving is, I think, largely unclear. Having said that, for like this future vision that I painted of the ZK cloud, where you would want people to do all kinds of like compute and not just blockchain related things, this I think will be a material thing to think about. But I think like it's too early to really move in that direction. And like we definitely want to at some point once there's like a commercial opportunity to do so.
So we got to the end of this conversation. I think it was, I enjoyed it a lot. It was full of insights and refreshing takes. And it was really fun to learn about where Gevulot is and where you guys are going. There's one last question that we ask all our guests, which is to name a project you are bullish about.
I think it might be controversial, but I am quite bullish on Alio. I have no idea what the market price is going to do. I don't really care. This is more about its sort of technological impact. I think it's demonstrating something that no one else has really been able to demonstrate in production right now, and that's like a combination of programmable privacy and like completely client-side compute. And I think that is, as much as there's bound to be controversy around all kinds of projects, I think that's really important and quite exciting.
Perfect. Thank you again, Teemu. It's been a true pleasure learning from you. For those of you interested, we've added some links in the show notes if you'd like to learn more and get involved with Gevulot. Finally, I want to thank Queenie for co-hosting with me. See you next time.